delete this line. Okay. So if we execute this one, and then we save it as the project. Go to project. Okay. So this is the first easy way to start the project. So just create your system model. When you run it, so your plan should appear on the workspace. See, it's your G, right? Your system, your starting point, right? And exactly the one that have been given on the project on the assignment.
เราไม่ต้องคุ้น
Okay, so then I said we are going to use
ยังไงก็ต้องหา
the tool called
มุมอยู่ดี
CISO tool. So you start typing the CISO tool and make what CISO to follow by the G, the plan. Okay, when you hit up
หม
enter,
ดเลย
it will pop up. Okay, it will pop up. And one is a sector. Yeah, coming.
มุมเราก็หาได้ด้วยแบบนั้น
Okay. Yeah, as a default, they have the full pop-up window. No, not the default, three of it. See, they have the body of both function, but the one that we haven't learned, but we learned later. Okay, and we have a locus. We have the step response. Okay, but okay, you can close this out. You don't need to have the body function. That's it. Okay. And move this guy here. Enlarge this one. So basically you have to window pop up. Right? Again, check out this one. This is the starting point. Remember for the loop locus, they start with the open loop. So this is where the current function loci. Okay, but the red point is the current gain. The current gain is what? The current gain we have not as the assignment. Yeah, actually you can consider 6 as a current gain. Yeah, right? But we just plug into the plan here. But it's not gonna make your system behave like you want it. You have to do some kind of adding some kind of controller. But again, the red spot here is a starting point, and this is the current step response, right? For CISO 2, if you move the red dot here, see, the system has changed. This one has changed. Okay. From here, notice something. If I move the red dot until I pass over on the right side of the system, what happened?
กลายเป็นความถี่
Unstable. See, it's unstable. Which is exactly what the theory said. But if we move the red dot back to the left-hand side of this plane, system becomes stable. Right. But again, you have each of you have to have your own assignment. Okay, you got to do. So the way to do it over here. Okay, we start this one. But first of all, you have to input your given F function, controller, G functions, which is grant we already have decided, and H function. But again, before we do it, check with your edit architecture. Okay, click it. See, there are many of them, like I said. But the one that close to our assignment is the first one, which is you have what? You have the plan here, you have your controller, the one that you're going to make it, you have your feedback function, you have the feed forward function, right? But see, each of them, they say block name here, value here, but they still have over here that if you click right there, you can import the plan. You can import it either from the workspace, but for the G itself, okay, you don't need it because you already have it, right? If we come back to the original function window here, double click on the G function, see the G pop up. These are already been put into the CISO tool. But for the others, for the F, yeah, the thing, the CISO tool allow you to input the F function this way as well, right? So you have two choices to either input the function through the workspace or double click on the function over here. For example, this one, let's have example. Okay, share what? Okay, share what? Share what? Who share what? Share what? Right. Okay, share what? Share what has given the F function is S plus 1 and feedback S plus 1, right? So we are going to put the S plus 1 to the system. S plus 1 here, the current one, the F, the default is 1. You just simply move your cursor right here, this area, and then choose your right click. You can either add 4 or 0, right? So for this one, is what? Should be 0 because this is what? S plus 1. Okay. Click here, add real 0. Location is what? Yeah, negative 1. S plus 1. The location of the port is what? It's minus 1. That's correct. But again, you can put any as you want it. Minus 1, whatever. But for the given of Taiwan is what? Minus 1. Right? Then hit enter. If we come back to our system here, the F there is now become S plus 1. And we delete it. I think so. Yeah, S plus 1. See? S plus 1. For the C, it's still only for the game, but we do it later on. Okay. We go to the G already have already put it. Then we go to the H. Let me explain it on this one. The H. For the H here, see the fixed rock is 1. But again, for this type of editor of architecture, they won't allow you to import the H function to this window. I just found yesterday. But for the F here, you can do it, right? For the G, for the C controller, you can do it as well. For the what? For the G, have already been included. But for the H here, no, they won't allow you. So the easy way to do is what to do by import it to the workspace. which means for the Taiwan case, for the MATLAB, you should create the H function on the workspace. Okay, like this one. Okay, back to the MATLAB. Okay, I said for the H function is what? Is transfer function of 1 and 1 and 1. Oh no, 1 and 1, right? S plus 1. Yeah, this could be the H function. Check it out. Suppose we execute this line here. S plus 1. Yeah. So which means, so basically you can import every function to the MATLAB. Okay. But I just want to tell you that there are two methods to input the function. The first one through this window, to the architecture editors. The other one is to go to the data browser. But for the data browser, for the H function, they won't allow you. I don't know what happened. I don't know why. But again, it's not problems because we can easily import to here, right? See, once we execute H here to the MATLAB, okay, let me execute the whole thing again. Execute the whole thing again. See, you got H function here. See, in the workspace, you got what? G and H already exist in the workspace. Alright? So, back to the CISO tool. Even though H won't allow you to import the function, but you can use right here. Click here, see import data for H function. Then go to pick up the H1, which is already exists in your workspace. So import. Done. So right now it means the H function we imported. I think so. But don't you have shoot up. For F here, you got right here, right? F function is correct. For the G, right here, and for the H function. How come it's still 1? If we make something wrong, H here, import from data, H imported. Okay, okay again. Yeah, need to click OK. Click OK here, and then when you start, click H. See, S plus 1 now. Alright? So make sure that you import everything back correctly according to your assignment. For the F here, we got locked in. So best way, I recommended, don't need to use data over here, right? You just simply create your function to your MATLAB, right? Do with the F. F the same as H, right? Okay, but for G itself, we need to make it, but we don't need to make the G function early. Let's execute this thing again. Now you get G, H, and F already. Now back to the CISO tool. Your job is to import it. Import it. C, controller, F. Okay, let's click F here. You choose what? F. F, right? Import it. See, okay. Update the architecture. Okay. Let me show again. For the F here, you got S plus 1. Here, when you correct F plus 1. See, in the middle right here, you got S plus 1 for the function. For the H, still S plus 1. Right? For the G, still this guy. Even function. You have that only for the controller. Right? Which means right now, if we don't have any controller, just have only for what? For the F function and H function through this diagram. You can just start one here. You got your plan here. You have no controller, just only one. You have H here. This is the current system response. Alright? But our point is, you got to go to this one. For example, like this. For Chaiwan, have given that the setting time and overshoot and steady state error. So for the CISO tool, it's very easier to create a window. You move your mouse to the step response window. Use your right click here. The same that you use as I tell you. And go to what? Design requirement. Okay. For the design requirement, you say what is new. When you click the video, this will appear and say this is your input parameter. For say what is it? Again, setting time is 10 seconds. Overshoot is what? 20%. Back to this one. For setting time, 10 already. For Chaiwan doesn't have the rise time. So actually it should have rise time as well. I say, okay, leave it. Overshoot is what? 20%. 20%. But for the others, you can manipulate it. It doesn't matter. But for this one, doesn't have the steady state error. But again, steady state error actually depends upon the system type, remember? For this particular system here, which is type 0, what is the steady state error for state function? Remember?
Like that.
If I
Less than. Less than.
we haven't go to the final yet, but you still forget everything. Where's my notebook? Where's my one note here? See, for the lecture 8, yeah. For lecture 8, right here. See, very important table. They said for system type, which is the feedback, you got this type of step. Once we apply the step input, you got this much steady state error. Okay? But for the impulse, you have none steady state error. Only for system type, but if we change the input to be rampant or parabolic, steady state will go wide. But again, your assignment is focused on controlling the steady state error, which is this much, alright? Because you guys have been given the same system, which is the type 0. So each of you, if you need it, you can compute the KP. Remember KP? The constant position, the position constant. The KP is what?
ข่าวหาไปเปิดแล้ว
This is KP, right? The limit of function only when you take the s go to 0 can complete. Okay, back to our this one. For the CISO2, now for the Chirac case, you just input the constraint setting time 10 seconds, overshoot 20. Again, for the other, you can check it. It's not obligation, but again, let's leave it. Okay, as a default. And then when you click OK here, check with this one. When you click OK, the window has coming, but it's too wide. Okay, let's we double check again design requirement in it. If I see, because the time is very short. If we just reduce the rise time to 1, the window will change. See, the rise time is 1, which is over here is 1, right? Second. And the setting time is 10, it's okay. Overshoot 20. When you close it, see, you got the window right here. This is a constraint that you got to make your system running not beyond those windows, those lines, like a frame. Okay, so you got a question. See, if we change the setting time to 5, okay. Alright, and rise time to 0.5. What happened? Oh, see, the window changed, right? So basically the window rise time is 0.5, see? It's narrow. If we change rise time to 2 seconds, see, it's expanded. Basically, this one is just the design requirement like a framework that you have to make sure that your final response has to go inside this frame. Yeah? Did you understand? Say, for example, like for Digit, right? Digit, what's your assignment? 15 seconds and 20% overshoot. So for the design requirement here,